So our first example, you've got 5 square feet going into square inches. Now the thing you have to remember, being squared units and cubed units, the conversion factors change. So 5 square feet, you put it over 1. We're going from square feet into square inches. 1 square foot is how many square inches? Does anybody remember? $144. So now the square feet cancel out, and that's 5 times 144, which is 720 square inches. How many of you just used 12 for that? Nobody's going to admit to it? Good. Well, hopefully you caught that one. So then square feet into square yards is the same thing. We have 54 square feet. When we go to convert that into square yards, 1 yard is 3 feet, but 1 square yard is 3 by 3 or 9 square feet. So square feet cancel out. Now this time, since the 9 is on bottom, we're going to divide by it. 54 divided by 9 is 6 square yards. Show of hands, how many of you have the first 2 right so far? That's not a good average.
No, it seems like they said they forgot.
Okay. Okay, well, we'll keep going over them. Number 3, 87,120 square feet into acres. Anybody remember how many square feet's in an acre? Anybody happen to write it down?
1,076.4.
Something's a little off there. There you go. Somebody's got it. 43,000. There it is. 43,560. Perfect. So that cancels out. Now, since the 43,560 is on bottom, we're dividing. 87,120 divided by 43,560, if I did my math right, should be 2 acres. Over here, 2 feet cubed, 2 cubic feet, going into cubic inches. This is going to be a different conversion factor yet. Up here, when it was square inches and square feet, 1 square foot was 144 square inches. The 144 comes from the fact that it's 12 inches in a foot, and a square foot is 12 by 12, which is the 144. Well, if it's a cubic foot, it's 12 by 12 by 12, or 1,728 cubic inches. Since that's on top, the 1728 is on top, 2 times that, we'll multiply it, 3,456 cubic inches. We'll come back to the standard areas and volumes a little bit more in a bit. We'll do some conversions with them. Metric. If you remember, for the metric system, we had meters in the middle. That was our standard unit of length, our only unit of length. Then we had prefixes that cut it up into smaller pieces or combined it into larger pieces. Decimeter was 1/10 of a meter. Centimeter was 100th of a meter, and millimeter was 1,000th of a meter. Decameter was 10 meters. Hectometer was 100 meters, and kilometer was 1,000 meters. And if you recall, when we converted, if I had 430 centimeters going into meters, to convert, all we did was we looked at the chart and we followed the decimal point. To get from centimeters to meters on our chart, from centimeters to meters, we have to move 2 spots to the left. So the decimal point in our number moves 2 spots to the left to get from centimeters to meters. 4.3. The reason that worked, if you recall, is because every position on the chart was either multiplying by 10 or dividing by 10. If we're going to the left, we're dividing by 10. If we're going to the right, we're multiplying by 10. And when you multiply or divide by 10, it just moves the decimal point one place. Well, when we go back up to this problem, it's not meters and centimeters anymore. It's meters squared and centimeters squared. And when that's the case, now every spot on the chart is no longer multiplying or dividing by 10. It's 10 by 10 or 100. So now every spot on the chart is multiplying or dividing by 100. And when you multiply or divide by 100, the decimal point goes two places. So to get from meters to centimeters, on the chart we have to go two spots to the right. But since every spot on the chart, since this is square meters and square centimeters, every spot on the chart is two decimal places. So we went two spots to the right on the chart. We have to double that. Our decimal point has to go four spots to the right. So 1, 2, we've got to add a 0, 3, another 0, and 4. So that is 14,000 centimeters squared. In the next one here, 280 millimeters cubed into centimeters cubed. When it is cubed, each spot on the chart again is no longer 10. It's 10 by 10 by 10. 10 to the third power, 10 cubed, which is 1,000. So when you multiply or divide by 1,000, the decimal point moves three places. So now every spot on the chart moves the decimal point three places. So going from millimeters to centimeters on the chart is one spot to the left. But we have to triple that because every place on the chart is three decimal places. So one spot on the chart becomes three decimal places in our number. We go 1, 2, 3. That is 0.28 centimeters. Let's do some more of those since we're working with the metric system. Let's keep it up. So I'll leave my chart on the top of the page here. Let's look at um, 2.3 centimeters squared going into millimeters squared. So if we look on the chart, we are going from centimeters squared to millimeters squared. So on the chart, centimeters to millimeters is one spot to the right. But since it's squared, what do we have to do to that one? We double it. Squared means we double the spots. Every spot on the chart is two decimal places. So one spot to the right becomes two decimal places. So we move 1, 2, we've got to add a 0. That becomes 230. I might have 47,000 centimeters cubed going into meters cubed. So centimeters cubed to meters cubed. On the chart, centimeters to meters is two spots to the left. Do we double it or do we triple it? It's cubed, so we triple it. So two spots to the left becomes 6 spots with the decimal point. So the decimal point, since there isn't one, starts out at the end of the number. We have to go 6 places to the left. So 1, 2, 3, 4, 5. We have to add a 0 to get 6. So that is 0.047. So let's say we have 0.38 meters squared going into millimeters squared. I'm going to give you guys a couple seconds to think about this as we go through. First thing I want you to look for is to go from meters to millimeters on the chart. How many spaces in what direction? From meters to millimeters is 3 spots to the right on the chart. So you know it's 3 places on the chart, 3 spots. To get our number of decimal point places, it's either the same, it's doubled, or it's tripled. Well, if this were just regular meters and regular millimeters, we would just go with the 3 spots. Since it's squared, that means we double it. So 3 spots times 2 is 6 decimal places. So my decimal point has to go 6 spots to the right. 1, 2. We're out of places, so we got to start adding zeros. So 3, 4, 5, 6. That's 380,000. Oh, we might have 5.2 millimeters cubed into centimeters cubed. I scrolled the chart off the top of the page on purpose here. Hopefully you either have it written down somewhere in your notes where you can refer to it quickly, or you've got it memorized. So again, we ask ourselves, from millimeters to centimeters on the chart is 1 spot to the left, from millimeters to centimeters. It's cubed, millimeters cubed and centimeters cubed, so we have to triple that. So times 3 means 3 decimal places. So our decimal points right here, we've got to go 3 spots to the left. 1, 2, we've got to add a 0, 3. So that is 0.0052. Is that coming back to you? Okay. So the metric ones aren't too bad. The standard ones were a little bit trickier, if you recall. 1 foot, of course, equals 12 inches. Well, 1 square foot is defined to be 1 foot by 1 foot, which is 12 inches by 12 inches. So 12 inches times 12 inches gives us an area of 144 inches squared, or square inches. If you look at that, that's just taking the 12 squared, or 12 by 12, 12 times 12. If it's 1 cubic foot, 1 cubic foot is defined to be 1 foot by 1 foot by 1 foot, which is 12 inches by 12 inches by 12 inches. So the volume, 12 times 12 times 12, is 1,728 inches cubed. Those 3 come up often enough that, again, just like with the metric conversion chart, you may want to have a spot in your notes where you have those written down where you can refer to them quickly. So if I go to convert, eight square feet into square inches, I've got my 8 square feet. Square feet are going to go on bottom here, square inches on top. 1 square foot is, it's squared, so it's 12 times 12, which is 144 square inches. 8 times 144 is 1,152. square inches. If I have 3,456 square inches and I want to convert them into square feet, same process. 3,456 square inches over 1. Square inches are on bottom, so they cancel out. Square feet on top. 1 square foot, again, is 144 square inches. This time, since the 144 is on bottom, we divide by it. So 3,456 divided by 144 is 24 square feet. If I have 3 cubic feet going into cubic inches, three cubic feet over 1. Cubic feet on bottom, cubic inches on top. 1 cubic foot is 1,728 cubic inches. So, okay, so the cubic feet cancel out. It's going to be 3 times 1728. So 5,184 cubic inches. Or the other way, we might have 864 cubic inches converted into cubic feet. So 864 cubic inches over 1. One cubic foot is 1,728. Since that is on bottom, we're going to divide by it. Oops. 864 divided by 1,728. If I did it right, it should be 0.5. There we go. Is 0.5 or 1/2 of a cubic foot. So again, those happen often enough that you should be familiar with them. So keep those numbers handy somewhere. That 1 square foot is 144 square inches. 1 cubic foot is 1,728 cubic inches. Next, we're going to look at yards to feet. 1 yard is 3 feet. So that means 1 yard squared, or 1 square yard, is defined to be 1 yard by 1 yard, which is 3 feet by 3 feet. And the area of that, 3 times 3, is going to be 9 square feet. If I have 1 cubic yard, that is defined to be 1 yard by 1 yard by 1 yard. Or again, 3 feet by 3 feet by 3 feet. 3 times 3 times 3 is 27 feet cubed, or cubic feet. So here's the next set of conversions you should have somewhere. You should already have 1 yard is 3 feet somewhere, or have it memorized. But you should also have down 1 square yard is 9 square feet. And again, that's found since it's square yards and square feet. You take the 3 and you square it, or 3 times 3. And 1 cubic yard is 27 cubic feet. And again, since that's cubic, or to the power of 3, it's 3 cubed, or 3 times 3 times 3. So in doing those conversions, and this is a conversion I actually do quite a bit. I might have something like 567 cubic feet going into cubic yards. I used to pour a lot of concrete. So all concrete is ordered in, they just call it yards, but it's really cubic yards. And most of your buildings and dimensions are measured in feet. So you figure out your volume of concrete in cubic feet and make that conversion into cubic yards. So 567 cubic feet over 1. Cubic feet on bottom and cubic yards on top. 1 cubic yard is, look up here, 27 cubic feet. So the cubic feet cancel out. Since the 27's on bottom, we're dividing by it. 567 divided by 27 is 21. So 567 cubic feet is 21 cubic yards. Okay. Some other things we went over then last Wednesday. We looked at rectangles. Now, if you just see a shape like this and it looks like the corners are square in it, you can assume it's a rectangle. Technically, I should tell you that the corners are square, or give you the sides and give you at least that one corner is square so you can figure it out from there. So let's say this is 8 inches by 18 inches. Its area for a rectangle is just length times width. So for this rectangle, the area is going to be 18 inches times 8 inches. Well, 8 times 18 is 144. We also multiply the names. Inches times inches is inches squared. You might recognize that, by the way, is also 1 square foot. If it wasn't a rectangle, if it was a parallelogram like this, so obviously these are not right angles in the corners, but if you're given that this is 32 inches, the end here, if I tell you that this is 18 inches, that doesn't mean much. What I need to know is this perpendicular distance between the two sides, the two 32-inch sides, or what's called the height. If I tell you that that is 16 inches, now my area is found. Remember, area is always found by multiplying two perpendicular dimensions. So the area here will be the 32 inches times the 16 inches. 32 times 16 is 512. Inches times inches is inches squared. To do a little review, if I wanted that in square feet, one square foot is how many square inches? 144, there we go. So since the 144 is on bottom, we are dividing by it. So 512 divided by 144 is 3.556 square feet. So 512 square inches or 3.556 square feet. Then we ran into trapezoids. A trapezoid is just a four-sided figure where two sides are parallel and the other two sides are not. So these two sides are parallel. Those sides are what we call the bases. And when we're dealing with a trapezoid, if you recall, we basically turned it into a rectangle, like this. So if I have the top of this is 16 inches, and the bottom of this is 48 inches, the height of the trapezoid, let's put that at 24 inches. The rectangle that this forms in the blue there, the purple now, is still 24 inches high. We need to find the length. Remember we said the length was exactly between the 16 and 48. It was exactly between the length of the two bases. So it was the average of the two bases. So it's the average of the bases times the height. So the average of our bases is going to be found by just doing 16 plus 48, then divided by 2, and then times our height of 24. Now when you do this on the calculator, or if you do this on the calculator, you type in the 16 plus 48. Make sure you hit equals before you divide by 2. Otherwise, it's just going to divide the 48 because order of operations says you divide before you add. So 16 plus 48 gives us 64. We divide that by 2 to get 32. Times 24 is 768. What units is going to go on that? Inches squared. Perfect. Good job. Those are all in inches, so that becomes inches squared. Our last shape we looked at then, at least as far as our straight-sided shapes, was a triangle. So we could have a right triangle like this, where this might be, let's say this is 28 feet by 9 feet. We found its area because it was related to a rectangle. And the area of that related rectangle would have been 28 feet times 9 feet. Since the triangle is exactly half of that rectangle, we divide it by 2. So 28 times 9 divided by 2 is, what's that at? 126 square feet. I better double check it. It is. Okay. But it doesn't, this was a right triangle. I gave you that this was a right angle here by putting the little square in it. It doesn't have to be a right triangle. It could be a triangle like this, which is obviously not a right triangle. Let's say this is 30 inches here. We're still going off of that related rectangle. That triangle would be half of that kind of dashed blue rectangle. So the 30 would be the length of that rectangle. But the other dimension we need to know would be this dimension right here at a right angle. That would give us the height of that rectangle. If I am told that is 8 inches, that is what we would call either the height or sometimes called an altitude of the rectangle. So the area of that, or sorry, of the triangle, I should say. So the area of that triangle is the base, 30 inches, times that height of 8 inches divided by 2, or 120 square inches. What if we are given a triangle like this? And we're told that this side is 8 inches, this is 15 inches, and this is 17 inches. Now, we don't know whether this is a right triangle or not right now. But if we had a right triangle, with that being the right angle, the two sides that form the right angle are called legs. So that's a leg and a leg. The other side, the side that's away from the right angle, is called the hypotenuse. Now, of these three sides, which one has to be longer, the hypotenuse or one of the legs? The hypotenuse. The hypotenuse will always be the longest side of that right triangle. So if this were a right triangle, the 17 inches would have to be its hypotenuse. Now, I'm not going to label it as hypotenuse right now because we don't know if it's a right triangle. In a right triangle, there is a relationship between the legs and the hypotenuse. We normally label the legs A and B. It doesn't matter which one's which. And the hypotenuse gets labeled side C. The relationship is A squared plus B squared equals C squared. Called your Pythagorean rule or Pythagorean theorem, depending on what your textbook is calling it. That Pythagorean relationship, anyway, defines those right triangles. So now back here, I can test to see if this is a right triangle because I know that if it were, 17 would have to be the hypotenuse. That would be called side C. 8 and 15 would be the legs, so I can label them however I want to. One of them is going to be A, and the other one's going to be B. And I know this relationship has to hold true. So that would mean 8 squared plus 15 squared would have to equal, I'm just going to put a box there because I don't know if it's equal yet or not, 17 squared. So 8 squared is 8 times 8, or 64. 15 squared is 15 times 15, or 225. 17 squared, 17 times 17 is 289. If I add 64 plus 225, I get 289. They are equal. Since they're equal, that means that this is a right triangle, and the right angle must be between the two legs, the 8 and the 15. So now to find its area, I can just do 8 inches times 15 inches, or 15 times 8, either way, and divide by 2. Because it's an area of 60 inches squared. So for this triangle here, in your notes, test for me to see, is that a right triangle? I'll give you a couple minutes to do that. Okay, so which two would have to be the legs if this is a right triangle? 6 and 12. So we're going to call those A and B. The longest one, 13, would have to be the hypotenuse if it's a right triangle. So we're going to call that one C. Again, I'm not going to put equals in there right now because I don't know if they're equal. So A is 6, so 6 squared. B is 12, so 12 squared. And C is 13, so we're looking at 13 squared. 6 squared is 36. 12 squared is 144. That adds up to 180. Well, 13 squared is 169. Those do not equal. So this is not a right triangle. Now, at some point here soon, we're going to look at how would we find the area that, even if it's not a right triangle, and even though we don't know an altitude or a height, but we do have all three sides. And there is a formula we'll look at in a while of how do we find that area just given the sides of the triangle. We also looked at circles. Let's say we have a circle here with a radius of 4 feet. The circumference of that circle, the formula for circumference, C is equal to pi times diameter. For this circle, what is the diameter? It's going to be 8 feet. If the radius is 4, the diameter is double that, or 8. So that means the circumference is pi, or 3.14, times 8, which is 25.12 feet. Now that's still just feet because I took pi, which is just a number, times 8 feet. So that just stayed feet. I wasn't multiplying feet by feet. The area of a circle, if you recall, is pi times the radius squared. So for this circle, that is pi, or 3.14, times, we're going to use 4 now instead of 8, squared. So that ends up being 3.14 times 4 squared is 16. So that is 50.24. And that is square feet because 4 was in feet. So 4 squared, the feet would be squared as well. So 50.24 square feet. Now, as we mentioned last week, many of you have a pi key on your calculator. If you use that, this will come out slightly different. That'd probably be like 50.26. That is just fine on all my quizzes and tests. On my answer keys, I have both answers figured out and written down. So if you have either one of them, you will be fine. Whether you use 3.14 or the pi key. One application of area that's really useful is pressure. Pressure is equal to a force divided by an area. Now that can be rearranged to be, I think, a more useful form is that the force is equal to the pressure times the area. For example, if you guys are familiar with the hydraulic cylinder at all. Oh yeah? Okay. A hydraulic cylinder is just a cylinder, and inside that cylinder, one end has a small hole in it for a rod to go slide in and out, and inside there is just a disc that fits tightly inside the sleeve of that cylinder. And of course that rod comes out and has some sort of an attachment on the end of it so you can hook into it. There are hoses going into and out of that cylinder, depending on whether it's a one-way cylinder or a two-way cylinder. You might just have a breather over here and one hose going in, or you might have two hoses going in like this. If the pressure on this hose is 400 pounds per square inch, we can figure out how much force is going to be exerted by this arm of the cylinder. Let's say that this is a 4-inch cylinder. What that means is that inside of that cylinder is a 4-inch circle, 4-inch diameter circle. The area of that is going to be pi times, it's not going to be 4 squared. Why is it not going to be 4 squared? That's the diameter. Yeah, we want the radius, which will be half that, or 2 inches. So it's going to be pi times 2 squared. So that's 3.14. Ironically, 2 squared does become 4. So 3.14 times 4 is 12.56. That's going to be inches squared. Nice hairdo. So 12.56 inches squared. So the force that is applying, if I come back up here, the pressure, 400 pounds per square inch times 12.56 square inches. The square inches will cancel out, and I have 400 times 12.56, which ends up being, is that 5,024 pounds of force. So that 4-inch cylinder, if you can achieve 400 pounds of pressure, or 400 pounds per square inch of pressure, can exert a force of just over 5,000 pounds. Okay, so we want to move on to other areas. I showed you how to use the Pythagorean theorem or Pythagorean relationship to find whether a triangle is a right triangle. But we can also use it to find a missing side of a right triangle. If I tell you that this is a right triangle, and if I tell you that this side is 9 inches and this side is 40 inches, I can find that third side. The way I'm going to do that, of course, the legs are the two sides that make the right angle, so those are A and B. And right now my missing side X is side C, the hypotenuse. And at this point, I'm going to keep writing out the formula and plugging stuff in. So A squared plus B squared equals C squared. A is 9, so that's 9 squared. B is 40, so that's 40 squared, equals, I'm just going to leave it as C. I could put in X if I wanted to, but I'm just going to leave it as C for now. 9 squared is 81. 40 squared is 1,600. That still equals C squared. Next, I'm going to add those together. 81 and 1,600 is 1,681. Now that is C squared. I just want C. So to find C, I have to square root it. The square root of 1,681 is 41. So that hypotenuse is 41 inches long. In your notes, I want you to try to find, if this is 20 inches right here, and this is 99 inches, obviously not drawn to scale, find the missing side here. I'll call it side Y. So find that in your notes quick. Okay, so the 20 inches and the 99 inches would be sides A and B. Those are my legs. Y is side C. That's my hypotenuse. So again, A squared plus B squared has to equal C squared. So I plug them in. A is 20, so 20 squared. B is 99, so 99 squared. And hopefully that's going to come out to give us C squared. So 20 squared is 400. 99 squared. Is that 9,801? Somebody double check me on that one.
Yeah.
Yep, okay. So now we add those. 400 plus 9,801 is 10,201 equals C squared. And if we square root that, square 101, perfect. That's 101 inches. Perfect, good job. Let's change it up just a little bit. Let's say that we are told that this is 12 inches and 13 inches, and we are looking for this side. Now it is one of our legs that's missing. Now for me, it's always easier if I make the missing leg be side A, just because that's how I think. So let that be side A. So the 12-inch leg will be side B. The hypotenuse is once again side C. So A squared plus B squared equals C squared. So A squared, that's our X, or I'm just going to leave it as A, is A squared. We don't know that side yet. B is going to be 12, so that'll be 12 squared. And C is 13, so that'll be 13 squared. So still nothing to do with the A. 12 squared is 144. 13 squared is 169. Now, if I look at this, a squared has to be the difference between 144 and 169. So I can figure it out that way, that a squared has to be 25. The formal way of doing it, the algebraic way, would be to subtract 144. Give us that a squared is 169 minus 144 is 25. And then we square root. So the square root of 25 tells us that this missing leg is 5 inches. That is often a more useful version of the formula. We often will write it as c squared minus b squared equals a squared. It's often a more useful version of the formula because quite often we know that hypotenuse. We can get at the slope surface. It's one of the other, either the horizontal or vertical surface that we can't get to measure. So if I look at something like this, let's say this is 32 feet long, and I tell you that this is 17 feet, and I draw this straight down from this corner to a right angle, and I tell you that this here is 8 feet. If I wanted to find the area of this parallelogram, I would use the 32 feet. Then I'd also have to know that height. Those are the two dimensions I would multiply to find its area. To find the height, I have to recognize that this is a right triangle. And once I recognize that, I'll label this side A, this side B. Those are my two legs. They make the right angle. And the 17 feet is side C. So I'm going to use that version. C squared minus B squared equals A squared. So I've got 17 squared minus 8 squared equals A squared. 17 squared is 289 minus 8 squared is 64. That still equals A squared on the other side there. If I subtract 289 minus 64, I get 225. So 225 equals A squared. What do I have to do to that? Square root. Good. Square root of 225 is 15. So this is 15 feet here. So the area of this is 32 feet times 15 feet. 32 times 15 is what? 480? And feet times feet is square feet. So I'm going to have you look at this. Pretend that doesn't look lopsided. If that is 50 inches, this is 41 inches, and I tell you that the distance from here to here is 9 inches. In your notes, find the area of that parallelogram. Oh, let's see. What'd you get for the height here?
We didn't do it that way.
Didn't do it that way? What'd you do?
We took the height and we took that entire piece, we brought it over to the other side.
Okay.
And it was 1 times 50 minus 9 would be 41.
Okay, here's the thing. If I brought this over to the other side here, does that change this length at all? It doesn't. That's still 50, isn't it? So this is a rectangle. It's still 50, and it still has a height of this. So either way, we still have to find that height.
I was telling Tanner that, but he didn't believe me.
Sure. Well, now you know. So finding that height, I'll call that A. This is B. Those are my two legs. This is C. So C squared minus B squared equals A squared. Did anybody find that height? So 41 squared minus 9 squared is going to be A squared. 41 squared is 1681. Minus 9 squared is 81. We subtract 1681 minus 81. We get 1600 equals A squared. Then, of course, we still have to do what to that? Square root it. Yes. Square root of 1600 is 40. So A is 40. So if that's 40 inches, my area is 50 inches times 40 inches, or 2,000 square inches. Now, let's jump back about 40 minutes. Put that 2,000 square inches into square feet for me. Go to the nearest hundredth, or 2 decimal places. Guys, let's not throw stuff. So to do this conversion, 1 square foot is how many square inches? Somebody's got to find it. Guys, answer yourselves. 1 square foot is how many square inches?
144.
There we go, 144. So square inches cancel. Since the 144 is on bottom, we're going to divide by it. So 2,000 divided by 144. 13.88, I said to the nearest hundredth, or 2 decimal places. So that'd be 13.89 square feet. So let's look at one a little bit more intense. Let's say that this is 1,200 feet. Over here, let's see here. Ever have one of those days where your brain just doesn't want to work? Every day. I'm usually pretty good at making up problems on the spot, but it sometimes doesn't work for me so well. So let's do this. Let's say that this is that's not what I wanted. 802 feet. And that this down here is 80 feet. I want you to find the area of that in acres. Now there's going to be steps here. The first step is going to be to find this height. Find what that height is. Once you find that, of course, then you can do 1,200 times that height to find the area, and then convert it into acres. So I'm going to give you a couple minutes. First, find that height, and we'll double check to make sure you got the right height. So if I label these sides A, B, and C, C squared will be 802 minus B squared will be 80 squared equals A squared. 802 squared is what? 16,000 or 64,000? 643,204? 43, I gotta get it right. So 643,204. Thank you. 80 squared is 6,400. Perfect. Now we subtract those. What do we get? $804. Okay. And now, if we square root that, 798. So how many of you got 798 feet for that? Okay, a few of you did. That's good. So in the next step, find the area now and convert it into acres. I'll give you a couple minutes. Okay, so the area is 1,200 feet times 798 feet. So we're going to get 957,600 square feet. And now we got to convert that into acres. So put that over 1. Remember, our magic number for acres is 43,560 square feet. So we're going to, it's on bottom, so we're going to divide by. So 21.98 acres. Any questions on that one?
Nope.
Okay. So now in our next step, we want to combine shapes. So far we've just done simple shapes, a single rectangle, parallelogram, trapezoid, triangle, or a circle. Eyes up here, guys. So what happens if I combine shapes like this? So here's a rectangle with a half circle on the end of it. If this is 20 feet and this is 10 feet, and I want to find its area, well, I can add two pieces together. This is a rectangle and a half circle. So I'll call this piece 1 and piece 2. The area of piece 1 is just a rectangle, 10 feet by 20 feet. 200, perfect. 200 square feet. Thank you. The area of piece 2 is a circle. It's actually a half circle. It's going to be pi, or 3.14, times, what's its radius going to be? Well, it's 10 all the way across, so the radius will be 5 feet. So pi times 5 squared. It's only half a circle, though, so we're going to divide it by 2. So that's going to give us 39.25 square feet. We add that up, that's 239.25 square feet. So areas are what we call additive. you can find two smaller areas we'll add together to make a larger area. That's totally your style, by the way. Sorry. Now on that example, there was only one way to find the area. We had to find the area of the two smaller pieces and add them together. In this example, let's say that this is, we're going to go inches here, 28 inches by 15 inches here. And this piece here, we'll call it 12 inches by 5 inches. There are actually two different ways I could go about this. I could add pieces together. So I could cut this somehow into two shapes that I know. There's actually two different ways I could cut it. I could cut it across here and have two rectangles, or I could cut it across here and have two rectangles. Really is the same amount of work either way, so I'm going to leave it just like this. For rectangle 1 here, it's 15 inches tall, but I would need to know this dimension. What's that dimension going to be? I have 28 all the way across. I have 12 here. That piece has to be 16. Very good. Good job. So that area for piece 1 is 16 inches by 15 inches, or 240 inches squared. Piece 2 here. This is 12 inches here. What's this dimension going to be?
10.
10. Perfect. It's 15 all the way up. We subtract the 5. We're left with 10. Go ahead.
120
Perfect.
inches squared.
Perfect. 12 inches times 10 inches is 120 square inches, or inches squared. We add those to get 360 inches squared, or square inches is our area. The other method we could have used, rather than adding, is we could have used subtraction. What we could have done is we could have filled this in to make a big rectangle. That big rectangle would be 15 by 28. That would multiply to give us an area of 420 inches squared. And then find the area of this little rectangle that's missing and subtract it out. That little rectangle is 12 inches by 5 inches, or 60 square inches. And if we subtract 420 minus 60 is 360 square inches. We get the exact same area. And on this problem here, it's about the same amount of work either way. But there are problems where we won't have a choice. The problem we just did up here, the only way we could have done that is by finding two separate areas and adding them together. Now this next example, pretend that looks like a half circle. Let's say that's 18 feet and this is 20 feet. And this is because I didn't draw them very well. I'm going to give you that those are right angles there. The only way we could find this area here is to subtract. We would fill this in to make a large rectangle that has an area of 20 feet by 18 feet, or 360 square feet. And then we would have to find the area of this half circle. Well, what we do is we look at it as if it were a full circle. What would its radius be? Well, how far is it all the way across? 20. Perfect. So the radius has to be 10 feet. So the area of that whole circle would be pi, 3.14, times 10 squared. Since it's only half a circle, we divide by 2. So that would give us
314.
You're close. 157, right? 314 would be pi times 10 squared. When you divide it by 2, it's 157. So you're close. You're on the right track. So 360 minus 157 is 203 square feet. Now, I gave you two extremes here. I gave you one problem that had to be done by addition, one problem that could only be done by subtraction. Most of the problems you do you'll be able to go either way with them. Just one might be a little less work, or maybe for you it's easier to see it one way or the other. Some people don't see the subtracting really well, only see chopping into pieces and adding them up. And however it works for you, that is fine. One thing I want to talk a little bit about then is perimeter. Perimeter is just the distance around. Okay, the distance around an object, if it's a rectangle, it's pretty simple. If this is 24 inches and this is 7 inches, well, I'd find the distance around just by adding the sides. So I've got my perimeter is going to be 24 plus 7. Very good. This side over here has to be the same. It would be 24. And this side over here has to be the same as this one, 7. And yes, if we add those all up, we do get 62 inches. Now, I'm guessing you took a shortcut, which is your perimeter. I can just double. If I add the 24 and the 7, I can just double it, right? 24 and 7 is 31 times 2. Perfect. So what if I have a parallelogram? I say that this is 15 feet and 6 feet. To find its perimeter, I can add up all the sides again. What'd you get?
42 feet.
42, perfect. The same shortcut applies there. I can add the 15 feet to the 6 feet, and because these sides are the same as their opposite sides, I can just double that. I get 42 feet. Wonderful. We might have 12 feet, 35 feet. If I want to find the perimeter for this, what do I have to do? Got to find the hypotenuse. I got to find the third side. So my legs are A and B. My hypotenuse is C. So A squared plus B squared equals C squared. I'll fill in. A is 12, so 12 squared. B is 35, so 35 squared equals C squared. So 12 squared is 144. 35 squared is 1,225. If I add 144 and 1225, I get 1,369. Then I have to square root. I get 37. Perfect. Perfect. Their perimeter is, yes, then 37 feet plus 35 feet plus 12 feet. And as you said, it's 84 feet of perimeter. We've already found the perimeter of a circle. If I have a circle with a radius of 4 inches, how do I find its perimeter? Well, the perimeter of a circle is just its circumference, which is pi times diameter. So for this circle, that would be 3.14 times, would it be 4 inches? 8 inches, there you go. So 3.14 times 8 inches, or 25.4 2 inches. So what if I give you this shape again? And I ask you to find the perimeter. Well, it's going to work the same way. I have 12 feet plus 10 feet plus another 12 feet plus whatever this arc is, this half circle is. Well, that circle has a diameter of 10 feet. So the circumference, if it were a full circle, it would have a circumference of pi, or 3.14, times diameter of 10 feet. So it'd have a circumference of 31.4 feet. But it's not a full circle, so that has to be divided by 2. You get 15.7 feet. That is the distance around that half circle. So that makes the perimeter of that, if I add those all up, 49.7 feet. Sorry. Okay. Now, I gave you some homework last time. I know it was a week ago. I was sick on Friday, so actually I had absolutely no voice, so I figured lecturing over the network with no voice was kind of pointless. But last Wednesday, I had given you page in the big book. I had given you page 249, exercise 8-5, page 250, exercise 8-6, page 269, exercise 9-5, page 270, exercise 9-6, and in the little book, I had given you units 21 and 22. Did you guys get time to finish those all up?
Yeah.
Perfect. So then new stuff that I'm going to add today. This is also in the little book. Units 24 and 25. Again, just the odds as always. Now there is a quiz I was going to give you today, but I know I went long. I want to ask, do you guys next week, do you guys have classes just Monday and Tuesday, or Monday, Tuesday, Wednesday?
Monday and Tuesday.
Just Monday and Tuesday, okay. That's the same for us too, so we won't miss a class. But you do have the quiz there. If you guys find some time to do the quiz since we won't have any classes next week, if you find some time to do the quiz, that would be wonderful. Otherwise, we will take class time at one point if we need to. So I'll leave that up to you, Mr. Berghammer. If they get some free time, they can work on that quiz.
Are you gonna send me the quiz then today or tomorrow or what?
I thought I had sent it to you. I'll make sure I resend it to you, though.
Okay, thank you.
Okay, thanks.